Hey, welcome back. This is Scott. So I'm continuing my little series on beginner stats in R, starting very basic stuff. Hopefully you were with me on what I called R200, beginner stats in R concepts populations, because this is so important to understand the difference between a population parameter, a sample, and a statistic. And then how those are used in both descriptive statistics as well as inference. So I'm going to continue on with those definitions. And so this particular video is going to be on central tendency and variation. And so what we're going to do is we're going to suppose that we have a sample of that's drawn from a normal population. So we're taking a subset of a normal population and we're using R to do that. And so what we're going to do is we're going to set seed to 222, which we can reproduce, means that we can set this over and over and we'll get the same results. Otherwise, if you don't set the seed, you will not get the same results when you do this R norm. It will change dynamically, stochastically. So anyway, what I'm doing here is I'm setting the seed here, and then I'm just going to do a norm sample, 100 observations from what we call a standard normal distribution. So 100 is the number of observations, 0 is the mean, and 1 is the standard deviation, standard normal. All right, so now I have that in this variable called norm sample, and then I'm going to, if you join me on R202, we basically drew a picture of what this distribution looks like. There's the histogram, and then there's the actual overlay, the kernel estimated density for this histogram. So that's what that looks like. And then one of the useful things in R is this head function. So if I execute it, and I'm just holding the control key down and hitting enter as I go through, and then in the console I can see that these are the first few observations from this sample here. If I want to know the number that are observations, which should be 100, I just click on that, and sure enough, I get 100 observations. And then if I want to look at some of the basic statistics, the summary, you would think, would provide actually more than it does. If I do the summary, it is useful. It does provide the minimum here for the sample, the maximum for the sample, as well as the first, what's called the first quartile, which is the 25th percentile. In other words, if you were to order these from low to high, this would be the very lowest you would get, this would be the very highest, and this would be the 25th value out of this 100 observations. This would be the median or the 50th value in that ordered set of observations. And then this is the 75th percentile of those. And then this is the mean, which is the average. So you sum up all the observations, divide by the number of observations, and then you get the mean. Everything here except for the mean is what's called a nonparametric statistic. It's actually a percentile, quantile is another word for it. The mean is a calculated value, and it is mathematically the best estimator of what's going to be the population mean. So again, we're taking a sample here, we're calculating the sample mean, and then we're trying to make an inference or judgment about the population mean. That's where we're headed in this series. All right. So that's, if you use the summary, that's what you get. And then if you want to do these individually, here's just some functions you can reproduce. Here's the mean, and then here's the median, and then here's the, well, I won't get into scale. Let me just exit that. And then the thing that's missing here is this tells you all about what the center of this distribution is. If you can see, I'm trying to mouse over the picture, the chart here, histogram and estimated density of this thing. And of course, it centers closely to around 0, which it should, because that is what we're sampling from, the population that we're sampling from. But it doesn't tell us how far off, how much it varies. So again, if you remember back when we sampled, we said it was a standard normal, means that there's one standard deviation. So 68% of the value should be between -1 and +1 here, if we did this over and over again. So we need to know some idea of the spread, and this is the standard deviation function in R, and that's somewhat useful. And we can break down and get into this as the series goes along. I want to move along, and I get bogged down. So again, here, I guess the last thing that I could do is just speak about parametric and non-parametric for just a second. Again, percentiles are non-parametric, averages, means are going to be parametric, and where that's really going to matter is whether we're trying to describe what the population looks like or actually make a mathematical statistical inference about the parent population that we're sampling from. So non-parametrics, robust, those are robust statistics, and they don't assume some sort of form that the parent population follows. However, in this particular example, we are sampling from a parametric distribution. We're sampling from a normal distribution, and we'll talk a little bit about the differences there and where that applies. We'll probably do some simulations and things like that. I'm going to leave you kind of with a little, I mean, we're covering really very basic stuff in R, but just to leave you with one of the things that you can do in R, you can do so much, but this is we're going to actually create a function called CV, which is the coefficient of variation. Standard deviation is good, but in most situations, you really don't know the relative measures, right? So we have two relative measures here. We have the central tendency, the scale, and then the distribution, how wide it is. So you can imagine, what if this was 1,000,000, right? And we were, instead of focusing around 0 with a 1, 2, we were actually having 1,000,000 with 1 or 2. So what that would look like is it would look like a spike here, because 1 or -1 doesn't really mean much when you're talking about 1,000,000, an average of 1,000,000. However, when you're talking about an average of 0, plus or minus 1 means a lot. So how can you relate those two things? What you can do is you can relate it with what's called the coefficient of variation, and this is the definition of the coefficient of variation. And this is how you define a little function within R. These are functions, this SD, this mean, this median, these are all defined internally within R, and then you can define your own as well, and this is the way you do it. And so this is going to be, the coefficient of variation is the standard deviation divided by the mean. So if I define the mean as this average of this normal sample, standard deviation is the standard deviation of the normal sample, then I create the function right here, and then I compute that coefficient of variation. It's 9116.709. So anyway, I hope that's somewhat useful. That's actually, I should say very specifically, that's 91.16%. So it's not 9,116. It's actually, these are in percent. So that means that this varies as 91%. We were actually sampling from a standard normal, which would be 100% of the mean. So we're close there with this particular sample. Anyway, I've probably gone too far. I hope you can join me next time where we kind of move on through this series. Thanks.